All right, guys. So this is section 8.4, where we are going to look at angle relationships. And the essential question is, how can you use angle relationships to solve problems? Okay. There's a decent amount of vocabulary in this one, so be ready for that. And we're going to start with that right now. So our first two vocabulary terms is adjacent angles and congruent angles. Now, adjacent angles means angles in the same plane, so they're on the same flat surface, that have a common vertex and a common side. So the picture over here, angle 1 is between this line and this line. Angle 2 is between this line and this line. So they share a vertex, this is the vertex, and this is the common side right here. Okay? So what this literally means is two angles that are next to each other. Okay? Adjacent angles are angles that are next to each other. So then we come to congruent angles. And remember, congruent in geometry means the same. So congruent angles are just angles that have the same measurement. So angle ABC, which you can see the symbol of it here, it's got the little shape. That means angle ABC, so from A to B to C, is congruent. This symbol here means congruent with angle DEF. And this is important right now because we need to know when two angles are the same, but we also need to be able to say the name of an angle. And the way that we name angles is by saying, well, it's between these 3 points. The angle formed by A, B, C. And that leaves no doubt that it's this angle right here. Okay. If I say the angle formed by DEF, you find those 3 points, DEF, there it is. That's that angle there. And we happen to know, based on this symbol down here, which is an equal sign with a little wavy line above it, that those are congruent. Congruent angles, congruent is this symbol here. That means congruent. Okay. Next vocab slide, we have a couple more words. Complementary and supplementary. These two are very similar ideas, and they get confused a lot because they are so similar. Complementary angles go together and add up to 90 degrees. So if I took angle B here and angle A here and I put them together, right, if I trace this one out and then I take that and I move it over here, you'll notice that that makes a 90-degree angle. Okay, so that is now 90 degrees. That means that angle A and angle B together are complementary because they add up to 90 degrees. Now, supplementary, on the other hand, is a really similar idea. Okay, it's a really similar idea, but supplementary angles add up to 180 degrees. So this angle at 30 degrees and this angle at 150 degrees put together make a straight line. So complementary is a right angle, and it's right to be complimentary to your friends, right? Huh? Yeah. And supplementary is 180. You only need to remember one to be able to figure out what the other one is. Okay? Complementary is a right angle. Supplementary is a straight angle. Don't forget. Vertical angles. So when we have two lines crossing like this, vertical angles are across from each other on the vertex. Okay? So if you look at these two lines and the angles 1, 2, 3, 4 going around here, they're color coded. Angle 1 and angle 3 are vertical. That means they're congruent. So angle 1 and angle 3 are the same angle. And similarly, angle 2 and angle 4 are the same angle. By the way, while we're talking about this, I want to point out that angle 1 and 2 here, 1 and 2 together, what do they make? They make a straight line. So they're supplementary. By the way, those are adjacent angles. Any two of these that are next to each other are going to be adjacent, and if they make a straight line, then they're supplementary. Okay? Vertical angles are across from each other. Adjacent angles are next to each other. Make sure you have this vocab written down. It is super important. And we're going to go into an I do problem. So this looks like a ton, but really there's only a few questions here. Okay? Definitely draw this diagram. I need you to draw this picture for sure. Make sure that these two lines are straight, and notice that this angle here with this little line coming off of point F is 90 degrees. Okay. So there's a couple of things that I need to do. I need to be able to figure out which angles are which based on the definitions, and I need to be able to tell you which angle is which using some names. Okay. So first of all, I'm being asked to name a pair of vertical angles. And what I'm going to do is I'm going to go and say, since this is my vertex, I'm going to go with this angle here and this angle here because they're across from each other. Those are vertical angles. And I know vertical sounds like it should be straight up and down, and I totally agree with you. If it was up to me, I would give that a different name, but it's not up to me. So I'm going to say that this angle here is angle AFB. So angle AFB is congruent to and vertical to this angle here, which is angle DFE. So that is a pair of vertical angles. The other pair of vertical angles I could have gone with here would have been from B to F to D, this angle here, ignoring this one in the middle, and angle AFE, ignoring this one here, because these are across from each other as well. So those are our vertical angles. So make sure that you have your diagram written and say vertical angles and then show this pair, okay? So now I need to show a pair of adjacent angles. Adjacent angles, remember, are next to each other. So I'm going to go with adjacent angles. They need to share a vertex, which we're going to share F in the middle here, and they need to share a line. So I'm going to go from C to D and from D to E. So my adjacent angles, the first one is CFD, and the one that goes with it that's adjacent to it is DFE. Notice that the point in the middle is always the vertex. So CFD goes from C to F to D. That middle point, the one with the vertex, always has to be in the middle of the name. DFE. Okay? So make sure you have that pair written down for adjacent angles. And there are a few other pairs of adjacent angles we could have gone with. We could have gone with this one and this one, or we could have gone with this one and this one. There's several different pairs. Supplementary angles, I need to remember that supplementary is 180 degrees. So supplementary angles make a straight line. So this is a straight line here. Here's our vertex. So this angle and this angle are supplementary. Okay? So I'm going to say that supplementary angles would be angle BF or AFB. It doesn't really matter which way you go. AFB, so here to here to here, and angle AFE. Those two angles together, should put my angle symbol in there. Those two angles together make a straight line, so they are supplementary. Okay. Now the directions are just getting more specific. Name two pairs of supplementary angles that include angle DFE. So I have to use this angle here, all right, and name two supplementary angles. So that one makes a straight line here. So I could go with DFE and AFE because those two together make a straight line. So that's one of my options. I could go with AFE to make a supplementary angle with DFE. Or, as another option, I have my DFE there, I could go with, let's see, this also makes a straight line. So I don't want to use C at all. I want to skip from here to make that straight line with DFE. So that would be BFD. So I could use AFE or I could use angle BFD. Okay? And now the very last question here. And this is taking a long time, but really you gotta look at it as not being very much work. It's just a lot of explaining. Okay, AFB. So I want to define that. So I go from A to F to B. So this angle here, right? Find the measure of that, and if you look, you'll notice that that's got an X there. Okay, so what I'm gonna do is use one of those properties that we've learned to solve this angle here. And what I want you to look at is I have this straight line right here, and this line here is 90 degrees. So if that side of it's 90 degrees, then this side of it's 90 degrees. So that means that this angle x, which is made by AFB, and this angle 50, those two add up to what? That's right, they're complementary. They add up to 90 degrees. So angle AFB and angle BFC together make 90 degrees. So that means that my angle x plus 50 degrees has to equal 90 degrees. So now I'm just solving for x. Take 50 away, and I find out that x equals 40 degrees. Okay, so there was a lot on this page. I want you to make sure that you drew the diagram and that you answered each of those, and that you're just saying, these two angles, vertical. These two angles, adjacent. These two angles, supplementary. Two pairs of supplementary angles that include DFE are AFE and BFD. And then the measure of AFB is this, and make sure you show this work, okay? This is important, so make sure it's written down. We have a we-do problem. It's a very similar list of questions. So the most important thing here is to draw this diagram and have that ready. Make sure you have all those points on there. This little 90-degree guy is very important. And we're looking for supplementary angles, vertical angles, adjacent angles, complementary angles, and to find the measure of CGD. So this right here is our unknown value x. Okay? Make sure that's on your output page and ready to go so that we can do that together as a class. All right, so we have another I do. So this is back on your input page. I'm being asked to find the measure of angle ZXY. So here's Z, here's X, here's Y. So I'm being asked to find this angle measure here. And I know that this angle measure here at WXZ is 35 degrees. And if you look, you'll see that those two angles together are complementary. And I know that you know that complementary means that this angle and this angle add up to, that's right, 90 degrees. Excellent job. So that tells me that angle 4x plus 7 degrees and angle 35 degrees are equivalent to, they add up to 90 degrees. Look at that. Now it's just a two-step equation. This is great. It's like geometry is built on algebra. So I'm going to combine my like terms here. I have 4x plus 42 equals 90. Now I want to get my x term by itself, so I'm going to begin by subtracting 42. Cross that out. Now I have 4x is equal to 48 is correct, which I now divide by 4 to find out that x equals 12. Now you got to be careful here. Every instinct in your body is saying you're done because you found the answer. You got to be careful though, because we found what x is, but if you look, x is not the angle. X is just a part of the angle. So what I need to do is I need to say, okay, x is 12. I'm going to plug that in here and figure out what this measurement actually is. Okay? So I'm going to say 4 times 12 plus 7. I need to figure out what that is. 4 times 12 is 48, plus 7 would be 55. So now I know that measure ZXY is equal to 55 degrees. And I know at least one person out there is saying, well, who cares about this? Why didn't we just use the 35 and the 90? And that's a really good point. 35 plus whatever this is adds up to 90. So 35 and 55 is 90. But it was good practice. We're going to see a lot of problems like this where we end up creating an algebra equation from a geometry picture. And geometry and algebra get along really well together. So we're going to do quite a bit of this. Make sure you have this written down before you move on. And we have a we do. Please have this diagram drawn. And the question is, find the measure of EHF. So from E to H to F, which is represented here by 2x. Make sure you have that so that we can do it together as a class. And finally, we have a summary. The question from the beginning was, how can you use angle relationships to solve problems? And don't worry, I will tell you what your summary should be in class. Thank you guys. Good job.